how did a company that started building planes no one remembers end up producing some of the most legendary aircraft of World War II? Before the P-51 Mustang, before the B-25 Mitchell, North American Aviation built trainers, unsung machines that taught nearly every Allied pilot to fly. The story of how those forgotten designs became icons of aerial combat begins with a single prototype in 1935. The prototype was the North American NA-16, a single-piston engine trainer that first flew on April 1, 1935. It was a modest starting point, yet this single design resulted in 1,935 built airframes. Rather than rushing into the competitive market of frontline fighters, company president James Dutch Kindleberger focused on pilot preparation. Kindleberger believed in designing for rapid production, building with simplicity, and keeping the assembly line moving. Under his leadership, the company established a clear institutional logic. Master the training pipeline first. The NA-16 served as a basic trainer, designed to teach aviation cadets the essential handling, flight discipline, and cockpit habits they would need before transitioning to faster machines. It was a forgiving but demanding airplane, built to tolerate mistakes while weeding out those unfit for combat. By focusing on this fundamental step, Kindleberger established the manufacturing baseline that would eventually turn a quiet builder of trainers into a wartime powerhouse, defining a design lineage that would soon stretch across the globe. In November 1935, North American branched out from basic flight training with the first flight of the XO-47 prototype. This single-engine observation aircraft, entering service in 1937, was built specifically for reconnaissance, artillery spotting, and photo mapping. The company produced 239 of these three-seat aircraft, featuring a glazed belly that gave observers an unobstructed downward view. At the same time, the company continued refining its training platforms. In 1936, North American introduced the BT-9 basic trainer, delivering 149 of the fixed-gear, metal-framed aircraft to the Army Air Corps. While the O-47 operated as a dedicated military tool in the field, the BT-9 focused entirely on teaching cadet navigation and instrument flight. By managing both programs simultaneously, the manufacturer proved it could deliver specialized designs to meet distinct and evolving military requirements. In 1936, North American stepped outside its traditional training niche with the XB-21, a twin-engine medium bomber prototype. Only one was built. During flight trials, test pilots reported severe wing flutter and underpowered engines, leading the military to reject the design. Yet, this failure taught the company exactly what it needed to improve. Chief Engineer John L. Atwood and his team analyzed the test data, realizing that future multi-engine aircraft would require stiffened wing spars and more powerful engines, lessons that would directly shape the future B-25 Mitchell. At the same time, the company began infusing combat capability directly into its instructional aircraft. The 1937 BC-1, with 270 airframes built, was the company's first basic combat trainer. It featured retractable landing gear, a reinforced center wing, and provisions for a forward-firing machine gun. By merging basic flight instruction with combat-ready features, Atwood's team translated early experimental risks into a solid manufacturing baseline. In 1938, North American's training platform expanded internationally when the British Air Ministry ordered the Harvard. This single-piston engine, advanced trainer, became a cornerstone of the Allied pilot pipeline, with 1,463 built to prepare overseas cadets for high-performance flight. Domestically, The company proved that minor engineering refinements were just as valuable as entirely new designs. In 1939, they delivered the BT-14, producing 251 of the single-piston engine trainers for the United States Army. The BT-14 improved on the older BT-9 by replacing the fabric-covered fuselage with an all-metal skin, installing a redesigned cowling, and reinforcing the wing spars. These incremental updates solved structural fatigue issues and minimized maintenance downtime in the field. By prioritizing durability and production continuity over radical redesign, the manufacturer created a highly dependable, standardized training environment that was ready to supply thousands of qualified pilots to a rapidly expanding military force. By 1939, North American aviation moved beyond merely building trainers to powering the entire Allied pilot pipeline. The single-piston engine T6 Texan drove this transition to massive industrial scale, with 15,495 built for the Army, alongside 3,867 SNJ variants produced for the Navy. These production numbers transformed industrial scale into a concrete military strategy. High manufacturing throughput directly enabled rapid pilot training. Under the standardized military syllabus, a cadet required 200 hours of flight time to earn their wings, with the final 75 hours of advanced instruction occurring inside the Texan's metal cockpit. Students had to master the machine's demanding characteristics to solo after just 27 hours of instruction. On flight lines from California to Texas, these instructors translated metal airframes into human combat capability. A typical morning saw an instructor demonstrate a stall turn before giving the cadet control, advising them to keep the nose up and watch the horizon. The resulting mark on the flight log determined who washed out and who went to war. This rigorous process ultimately produced 150,000 qualified pilots, establishing the massive human foundation that would soon dominate the skies of World War II. In 1939, North American aviation explored narrower design branches, proving that limited production runs could still yield vital engineering data. The company built just 13 of the P-64 single-engine fighters between 1939 and 1940. Originally destined for export to Peru and Thailand, these compact fighters were intercepted by federal export controls and repurposed as advanced military trainers. Simultaneously, engineers experimented with the NA-35 in 1940, a light primary trainer prototype featuring a fabric-covered fuselage and a 220 horsepower engine. Only one airframe was constructed before the program was abandoned, yet the exercise refined the factory's structural tooling. Far more successful was the NA-64 Yale, a robust, metal-skinned export trainer. Of the 230 built in 1940, over 100 went to France before the armistice, with the remainder serving in Canada. These niche contracts allowed designers to trial new metal skin techniques and engine integrations without disrupting major assembly lines, establishing invaluable technical baselines that would soon serve much larger programs. In 1940, North American aviation transitioned to direct combat manufacturing. The shift began with the A-27, a single-engine attack aircraft, though only 10 were built. The real scale of production arrived with the twin-engine B-25 Mitchell medium bomber. Introduced that same year, the B-25 was designed as a flexible tactical strike platform. On the assembly lines, thousands of factory workers and test crews drove a rapid manufacturing ramp-up, eventually delivering 9,890 of the twin-engine bombers. This immense industrial effort proved that the company could successfully scale up from training platforms to deliver heavy-hitting firepower to Allied crews. In October 1940, the single-piston engine P-51 Mustang took flight, carrying North America's manufacturing reputation directly to the front lines. The fighter was not a sudden breakthrough. Instead, it relied on years of strict design discipline. Using the laminar flow wing profile and retractable landing gear first tested on earlier training platforms, like the NA-35. These established production methods allowed factory floors to scale up rapidly. The company manufactured over 15,000 Mustangs, proving that systematic preparation could turn a builder of training aircraft into the producer of the war's most dominant fighter. Even as mass production peaked, North American continued pushing the boundaries of existing airframes. In 1942, the company developed the high-altitude XB-28, building just 2 of these pressurized twin-engine bomber prototypes to gather aerodynamic data. That same year, engineers adapted the Mustang design into the A-36 Apache, delivering 500 of these dive bombers to the front lines. By 1945, this process of constant modification culminated in the F-82 Twin Mustang, a twin fuselage escort fighter with 272 built. Each machine proved that North American's legendary successes were never final, but rather the result of restless, continuous adaptation. Which of these designs truly define the future of aviation? Today, this relentless design progression still shapes how we conquer the skies. As modern engineering faces its own rapid evolution, we must ask, are we still capable of such ground-up breakthroughs today? Or has that era of legendary innovation passed? Let us know in the comments.